Hello students, welcome for another lesson. This lesson is going to be about the sine rule. Here we will learn about the sine rule, including how to use the sine rule to find a missing side or a missing angle in a triangle. In the previous video we learned how to find a side or a missing angle in a right angle triangle. In there we used the Pythagoras theorem or the Tutopiya rule, but we can use sine rule to find missing angles or sides in other non-right angle triangles. We can use the sine rule to work out a missing angle or a missing side when we have information about an angle and the side opposite to it. Let's see how this works. Firstly, let's identify the sides of an angle. Now this is a triangle, but this is not a right angle triangle. What I'm going to do is I am going to mark these, I'm going to label this triangle. I'm going to label the vertex. There are three vertices in this triangle, that is 3 points. I'm going to mark them in capital letters, that is the uppercase. So I'm going to mark this as point A, B and C. So this angle can be called A, B and C. And the next is the side opposite to the vertex. That is, here we have point A, and the side which is opposite to this angle we will mark as A, but in lowercase, that is a simple letter. So in here this vertex is marked as B, and the side opposite to that can be labeled as B but in lowercase, and C, this is marked as simple C. So this is how we are going to label the triangles before we start with our sine rule. But you need to remember that capital letters A, B, C are used to label corners of a triangle, and lowercase letters A, B and C used to label the sides of the triangle. It does not matter which sides are A, B, C, but the vertex must be opposite the same letter on the side for the sine rule to work. That is, when you have capital A, you have to make sure that the opposite side is also labeled as A in lowercase. Okay, let's see what a sine rule is. Before we apply sine rule, we need to see if we are working with a right angle triangle or a non-right angle triangle. So this is not mentioned as a right angle triangle, so this is a non-right angle triangle. We do not use Pythagoras theorem or the Tutopiya here because it is a non-right angle triangle. If they have given two sides, one angle and two sides, or one side and two angles, we can use that information to find the missing angle or the missing side. Let us see. Here we have the simple A, the lowercase, A over sine A, that is the opposite. This is, yes, let me use a different color. This is the uppercase A. This angle A, we can apply the sine A, and the opposite to this is marked as, the side is marked in lowercase a. So A over sine A is equal to B over sine B, that is also opposite, and C over sine C. Even though there are three relationships between the three angles and sides, we can use two of them for the sine rule. let us see how we apply the sine rule and find the angles. How to use the sine rule? So now you must be familiar with the sides and the angles and how we label them. So you can see the capital A, B, C in the vertices and the sides A, B, C in lowercase in the sides, and they are opposite. How to use the sine rule? First, what you need to do is you label the sides and the angles and make sure you label it correctly. Like we discussed, the opposites should be with the same letter but in uppercase and lowercase. This is very important that we label them correctly so that we don't get our question wrong. First, we label the sides and the angles, and then secondly, we substitute the values, the informations that we know, we substitute for the sine rule given and find the missing angle or the side which they are asking for. Okay, let us see how to find a missing side using the sine rule. Looking at this triangle here, you will see that we have two angles, which is 21 degrees and 35, and we have the opposite of the 35 degrees as 23 centimeters and opposite of the 21 degrees as x centimeters. First, step 1, let us label the triangle. First, let the angles, sorry. So I'm going to mark this angle here as A and this angle here as B and this as C. And the opposite to the angle A, I'm going to mark this side as A in lowercase, and opposite to angle B, this side B in lowercase, and this as sine C. If you look at this triangle, we know that we have the value for angle A, we have the magnitude for B, angle B, and we have the side for B, and we need to find the length for A. Now we have labeled the triangle, let us substitute the values. So I am going to use the sine rule, which is A over sine A is equal to B over sine B. The rule. In this particular question, we need to find the length of a side. So what I do is, I write the length as the numerator here. That is A and B, the sides, the lowercase sides, as the numerator. And now let me substitute. A will be written as x and the opposite sine A as sine 21, and B will be written as 23 centimeters, 23, and sine B as sine 35. Now we have the equation, we have substituted. Now let's solve and find x. We have to make x the subject of the equation. You times both sides by sine 21 so that we can remove sine times sine 21, and we can cancel these off. So we have x is equal to 23 over sine 35 times sine 21. You use the calculator and feed the informations accurately, and you will get x is equal to 14.4 centimeters, the answer in 3 significant figures. Next, let us now see how to use the sine rule to find a missing angle. We have another triangle, and in here we have the sides. We have two sides and one angle, and we need to find x in here. So first, point 1, you remember that we need to mark the vertices and the sides. So I'm going to mark this as A and this as B and this vertex as C. It doesn't matter which sides are A, B and C, but the vertex must be opposite the same letter on the side for the sine rule to work properly. Okay, so we have marked the vertices as A, B, C in uppercase, and now we use the sides. So the side opposite to vertex A we mark as simple A here, and this is B in lowercase, and opposite to C we mark this as C, and we check whether we have labeled it correctly. Yes, we have. And now let's use the rule. Sine A over A is equal to sine B over B. Now here you must be noticing that I have brought sine A. When we wanted to find the missing side, I used A over sine A is equal to B over sine B. And in here I have used the other way around, which is sine A is equal to sine A over A is equal to sine B over B. That is because I need to find an angle. So I bring the sines as the numerator in here. Now let us substitute the values. Sine A, we know that we need to find the sine A. So sine A will remain as sine x. And A, we write 6.5 centimeters. And sine B, we have 52 degrees, which is sine 52. And B is equal to 12 centimeters. Now we make sine x as the subject of the equation. I times both sides by 6.5. Yes, and then I cancel this. So I have sine x is equal to sine 52 over 12 times 6.5. And I need to make x the subject. I remove sine, I move it to the other side as sine inverse. So we find the value of sine inverse of sine 52 over 12 times 6.5. I carefully use the calculator. I feed sine 52 over 12 times 6.5, and then I find the inverse of the answer, which I get x is equal to 25.3. You will know that this is equal to 25.3 and the answer in 3 significant figures. Okay. Let us now see some misconceptions that students will have, that where you can go wrong as students. First, the students can go wrong is the incorrect labeling. Like I told you, we need to mark in capital letters ABC and the opposite sides as in lowercase letters ABC, and we need to substitute it accurately for us to find the answer. So students can also label it incorrectly, so the answer would also be wrong. Number 2, not knowing when to use the sine and the sine inverse. When you find the missing angle, you must have noticed that we use the sine inverse, but when we use the missing side, we directly use the sine. So the students should know where to use sine and the sine inverse. Another common mistake the students do is you round off too early. Now, when we use the sine inverse, for an example, when we use the sine inverse and we had a value here, when the students use this sign, we have to say, let me make it as sine x times y or something like that. So we need to find the value of what is inside the bracket and do not round it here. You find the inverse and you need to round the final answer, not in between. Only the final answer should be rounded off. Don't round it off in between, like halfway through the question. Point 4. Some students, even though they label the triangles correctly, they can also make incorrect substitution. So we have to make sure that we substitute correctly. Okay students, I hope this lesson was very useful and very clear. Please do ask us any questions. Let's meet in the next session. Thank you so much. Bye.